In this video we're going to talk about two different things, but they're very related topics, so they go together nicely for us here. The first thing is circumference, which we know from before is just the distance all the way around a circle. And some people say it's the distance around the outside of a circle, but technically that's not right because the circle is just this sort of curvy line here. That's the circle. The interior here is called just that, the interior of the circle. The circle itself is just the curvy line. So circumference is the distance around that. I like to think about circumference as, imagine there was a tiny little ant here somewhere on the circle, and he had to walk, or she had to walk all the way around and get back exactly where they started. Where would that be? So that's circumference. And hopefully you remember from earlier that circumference, which we usually say is C, is equal to pi times the diameter, or sometimes people say it's equal to 2 pi times the radius. And that's just because the diameter is equal to 2 radii put together. The diameter is twice as big as the radius. That should be reviewed. That's nothing new. Arc length, though, that might be something new for you. In a previous video we talked about what an arc means, but an arc is just part of the circle. So on the picture over here I've highlighted in red the arc EF. So when we talk about the arc length, we're talking about how far is it from E to F, or from F to E. That's the same distance. Excuse me. So we're just talking about the distance around part of the circle, and we call that part of a circle an arc. There are two different things that people often get confused. Arc length, which we're going to talk about here, and arc measure. Arc measure is different. You use degrees, just like an angle. Arc length is an actual distance. It is a length. If you need to know more about arc measure, I've got a video about that as well. But here we're going to talk about arc length. Because arc length is just the distance around part of the circle, we're going to be talking about fractions. So to find the length of an arc, we just use fractions. And there's two different ways to look at this, and we're going to look at both. So we have two formulas. One where you set up two fractions and set them equal to each other. We call it a proportion. And our proportion would be arc measure over 360 is equal to arc length over circumference, C. And that should sort of make sense because the arc measure is the degrees for just my part of the circle. How many degrees is it here for EF? And 360 is the number of degrees around the entire circle. That should be equal to arc length, the distance around the circle from E to F, over the circumference, the distance all the way around the circle. So in both fractions we have part of the circle over the whole circle, part of the circle over the whole circle. It's just that in one fraction we're talking about degrees, in the other fraction we're talking about distance and length. So that's one way we can think about this. Other people like to write this formula differently, just kind of rearrange it with a little bit of algebra here. And if we just multiply both sides by C, well, what you'll end up with is that arc length is equal to arc measure over 360 times circumference. And these are just two separate formulas. Two separate formulas, so totally separate through here. I wanted that to be red. Totally separate. Two different ways of looking at it, but it's really the same idea. That the arc length is just a fraction of the circumference. And so you can either set up a proportion, like the first one, where you're looking at degrees in one fraction and length in the other, or down here, where you're sort of thinking about it in terms of multiplying by a fraction, taking a fraction of the circle. We're going to look at some examples of doing it both ways. Okay. In this picture, it says that the diameter of circle D, which remember that we name a circle after its center point, is 18 units long. Find the length of each arc for the given angle measure. Alright, so our first problem here, we're supposed to find the length of arc LM. Notice that it's an arc because it has the curve over the top, not a line segment where that would be straight. So we are looking for the length here from L to M if we were to travel along the circle. Remember again, we have our little tiny ant crawling along the circle, and we want to know, okay, if he started at L and had to go to M, how long would that be? So let's use the first formula for this one. Now remember also that the measure of the arc, our formula was arc measure, oops, I need to get my writer, not my laser there, arc measure over 360 is equal to arc length, oops, G went a little crazy there, over circumference. So the measure of the arc is equal to the measure of the central angle. So my central angle here, angle LDM, is 100. So the measure of my arc is 100. 360 stays as 360. Equals arc length, which I'm looking for. So I'm just going to call that L. I like to use a cursive L so I don't confuse it with a 1 or something like that. My circumference for my formula from before, I know that my circumference here is going to be equal to 18, which is the diameter, times pi. So that's what I'll have down here. 18 pi. I like to simplify first here. So actually I'm going to move this, I think. Oops, never mind. We'll just keep it there. Sometimes it doesn't like to move the way I want it to. If we simplify this, 100 over 360 can be simplified to be 5 over 18. And that equals L over 18 pi. When you cross multiply and work this out, you're going to get that, so we'll show, we're going to cross multiply here. 18 times 5 is going to be 90, but then I'm going to have to divide that by 18 because the 18 and the L were multiplied together. So really, what I'm going to get is just 5 pi equals my arc length. And you can check that yourself. Oftentimes with circles, when we're dealing with pi, we like to just leave that pi in the answer. Just kind of treat it almost like it's an x when you're doing the math, but it's not a variable, it is a number. And so sometimes we like to leave it like this is exact. Other times we like to actually multiply it out. And so if you check on your calculator and you typed in 5 times pi, you would get something a little more than 15. 15.708 was my approximation. And so I put the squiggly equal sign there because it's an approximation. We should know that it should be a little more than 15 because pi is a little bit more than 3, and 5 times 3 is 15. Again, you can check that yourself. Alright, so that's an example of doing arc length here. Let's look at a couple more just to make sure we're solid on this. Alright, let's do part B this time. Excuse me. Again, we're going to set this up here with arc measure, which I know is the same as the measure of the central angle. So I'm looking at the length of arc KL here. KL, that arc, and its central angle here is 60. So if I set up the same type of proportion as I did before, I've got the measure of the arc, which is the same as the measure of the central angle, 60, over 360, the degrees in the entire circle, is equal to my arc length, L, over my circumference, which is still 18 pi. It's not always going to be 18 pi, but each of my examples is from the same circle with a diameter of 18 units. So that's my equation to start here. Remember, degrees in my little part of the circle over degrees in the entire circle. Distance for my little part of the circle, distance for the entire circle. So it's part over whole, part over whole. Just kind of making sense of this. Again, I can simplify. 60 over 360 is 1/6 is equal to L over 18 pi. When you cross multiply, you're going to get 18 pi is equal to 6L. Divide, and 3 pi is equal to L. Again, I like to leave that pi in there. It's an exact answer. Sometimes, though, you'll want to get an approximate answer. When you do 3 times pi, you'll get L is approximately 9.425 units here. Again, we know it should be a little bit more than 9 because multiplying by pi, which is about 3. Let's look at just one more example. We're going to do this one using the other formula. So our other formula was that, not circumference, that arc length, L, was equal to arc measure over 360, that was our fraction, times the whole circumference. Because I don't want the whole circumference, I want a fraction of it. And so let's look at this example here with this version of the formula. Notice also that in this one, it's arc NJK. If you remember, the 3 letters don't really change anything about how the problem works. Typically, we use 3 letters only when it's a major arc, when it goes more than 180 degrees. In this case, they gave us NJK, which is less than 180 degrees, so still a minor arc. But what's important is that you just kind of go in order here of the 3 letters. So from N to J to K, that's my arc. To get the arc length, I need the arc measure, which is the same as the measure of the central angle. They tell me that this angle here, NDK, is 120 degrees. So in my formula, L is going to equal 120 over 360 degrees for part of the circle over degrees for the whole circle times circumference, which is still 18 pi because it's still the same circle. Then I'm just going to simplify and multiply this out. 120 over 360, well, that's 1/3. So I'm taking really here 1/3 of the circumference, which is 18 pi. 1/3 of 18 pi is 6 pi. Again, if you multiply that out for an approximate answer, 6 times pi is going to be about 18.85. So my arc measure is just a fraction of the circumference. And there's 2 ways we can look at solving that. Here we have the formula where we take arc measure over 360 times the circumference. In the other one, we had arc measure over 360 equals arc length over circumference. We showed that the 2 formulas are really the same, just cross multiply to rearrange things. Either way you do it is fine, your preference. But that should help you find arc length. And don't confuse arc length and arc measure. Read your problems carefully. Find a distance when you want length, find degrees when you want measure.